Hello and welcome to the C++ Insights YouTube channel. I'm Andreas. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. If you like the content I present here and want more details, your company can hire me for an on-site or remote training class. Feel free to reach out. Today I like to present a topic that came in with C++ 23 and it fixes an issue that is present in all the previous C++ standards. What I have here is a very downstripped version of, I would say, a regular program. I got rid of the regular stud vector here using my own very tiny vector implementation. The reason is I wanted to show you the details, and if I use the regular stud vector, there is just a lot of noise in the transformation. So what we need here is, we say we have this vector, imagine it's a stud vector, it takes a couple of integers here, and it has two member functions, begin and end, and they simply return in pointers. Why do they do that? Because that way this simple class here works with a range-based for loop. At least it compiles, and for this episode here it means that a transformation works. So this is the data structure we need. Imagine we have such one. And now here is another data structure. That's one that you most likely implement. I call that one keeper. I go simple in here. I only use structs. And that one now has a data member of this type vector here. And vector contains a couple of elements here. So I'm using in class member initializers. And then I have a member function here, items. And that one returns the data by reference. So this here is a vector ref. And along all that, I have a getter function, so it could be create or something, and that one returns me a keeper object, so an object of the class that I just created. Then down here in your beloved program, you want to iterate over all the items in the struct vector, so in keepers data. What you can do for that is you call get, give you a keeper object, and then say .items on that one, so more functional programming style. Iterating over it, grabbing a reference, call that one item to each element in this supposed container, and then do something reasonable with E. So this is, I use C++ 20 here, and if I do the transformation, and we can see I enabled a second transformation, and this is the show object lifetime transformation. That's a rather new transformation I added around mid last year. The purpose here is to show you object lifetimes in C++. So when are objects, specifically temporary objects, created, and when do they go out of scope? So when does their lifetime end? The note here, please read that carefully, says it's a hand-rolled transformation and it might be buggy or incomplete. But for this example, it works. So we can see my struct vector here, there's nothing to see. The same is for the struct keeper, nothing special going on here. And if you now go down in main, I had an earlier episode detailing range-based for loops internal. So this here is based on the fact that you've seen the previous episode. If not, check it out. Here we have the call to get, and now we can see this is what a new transformation enables us to see. The resulting value of get is a temporary object, and they are all named temporary with the line number and the column. The next thing the range-based for loop internal does is it calls items on the temporary object, assigning it to reference of vector. And now here you can see in this mode I'm not calling the destructor here, but imagine a destructor for the temporary object would run at this point. So the lifetime ends, but we still hold the reference here to the thing that was stored in items. So we have a dangling reference. And now if we go down further, we can see, of course, range is used here with begin and end, and then even dereferenced, while referring to some memory that no longer belongs to the original temporary object because it already went out of scope. This is a problem that comes in if you prefer a more functional programming style. Now in C++23, specifically Nikola Yusutis fought hard to fix this issue. If I do the same transformation in C++23, we can see, yeah, of course, we still get the temporary object, no doubt there. And this line also is the same. The temporary object, we call items on that one and assign the result to reference of vector. But the next lines are different, or specifically only the next line is different, because previously between line 33 and 34 there was the lifetime ending for the temporary object. That one now moved down to the end of the range-based for loop. So if you have this specific line of code, then if you use it together with a range-based for loop in C++23, you get lifetime extension for the temporary object items returns. And this makes this code now safe. Previously it was undefined behavior. Now in C++23 you can use that one safely. So maybe that's a reason to upgrade to C++23, because it will make your code safer by simply flipping the compiler switch there. I hope you learned something today and you now are better in writing undefined behavior free code. That's it for today. Thanks for watching.